On the 1st of July, NASA detected a mysterious object speeding toward Earth.
Something is moving through our solar system right now, and it is not acting like a comet, an asteroid, or anything nature has ever created. The James Webb Telescope just picked up metal signatures, gravitational distortions, and coded signals surrounding 3I Atlas, the third interstellar object in human history. And every new reading breaks another rule of physics. But the moment scientists matched its emissions to a mysterious echo coming from the far side of the moon, that's when everything changed. And when you hear what happened exactly 1 hour after that signal was detected, you'll understand why some researchers are quietly panicking. Where it all started. Let's rewind to where this story begins. July 1st, 2025. Astronomers working the night shift at the Asteroid Terrestrial Impact Last Alert System, or ATLAS, were conducting their routine sweep of the sky. They were looking for rocks that might threaten Earth, as usual, but what they found was anything but usual. There, sitting at 4.5 astronomical units from the Sun, just beyond Jupiter's orbit, was an object moving at an unbelievable speed. This thing wasn't from our neighborhood. It had traveled across the black emptiness between star systems to reach us. 3I Atlas had just become the third confirmed interstellar visitor in human history. Now, if you've been paying attention to space news over the past few years, you know we've seen this movie before. Back in 2017, we got blindsided by Oumuamua, the weird cigar-shaped object that came flying through our solar system, accelerated in ways we couldn't explain, and vanished before we could get a good look at it. Then in 2019, we caught Borisov, an interstellar comet that actually behaved like a normal comet. Nothing too shocking there. But 3I Atlas? This one's different. This one's special. And here's why. Size matters in deep space. To begin with, this thing is massive. Initial observations suggested a diameter of up to 20 kilometers across. As we watched it more closely, we realized we were seeing a coma, that fuzzy cloud of gas and dust that forms around comets. So the coma itself spans 20 kilometers, but buried inside that glowing haze is a solid nucleus, potentially 11 kilometers wide. That's 10 times bigger than Oumuamua, 5 times the size of Borisov. These interstellar visitors are getting progressively larger with each encounter. But size alone isn't what makes 3I Atlas extraordinary. It's where this comet came from that really deepens the mystery. Most of the stars in our Milky Way galaxy live in what astronomers call the thin disk. That's the relatively flat plane where our sun hangs out, about halfway between the galactic core and the outer rim. It's crowded, active, full of young stars and fresh planetary systems. But above and below this thin disk sits a less dense region called the thick disk. The stars up there are older, remnants from the early days of our galaxy, quieter, more ancient. 3I Atlas appears to have originated from the thick disk. If that's true, then we're looking at an object that could be more than 7 billion years old. Older than our entire solar system, older than Earth, older than the Sun, older than the planets. Play in background. This chunk of ice and rock has been drifting through the galaxy since before our cosmic neighborhood even existed. It carries within it the chemical memory of a stellar environment so different, so alien, that studying it is like opening a time capsule from another era of the universe. That alone would make this a career-defining discovery for any astronomer. But we're just getting started. The impossible trajectory. Now here's where things get weird. 3I Atlas isn't just passing through our solar system. It's taking what looks like grand tour. Unlike Oumuamua and Borisov, which came at us nearly head-on from the northern sky, 3I Atlas is hitting us from the side. A T-bone collision, cosmically speaking. And that sideways approach means it's going to fly past multiple planets on its journey through our neighborhood. First up, Mars. On October 3rd, 2025, 3I Atlas swept within 29 million kilometers of the red planet. That's close enough for spacecraft orbiting Mars to get detailed images. The European Space Agency's ExoMars Trace Gas Orbiter and Mars Express missions were perfectly positioned, cameras ready. Then it heads inward toward the Sun, passing relatively near Venus at about 97 million kilometers. And after swinging around our star, 3I Atlas will exit past Jupiter, coming within 53 million kilometers of the gas giant in March 2026. But as 3I Atlas makes its closest approach to the Sun on October 30th, Earth will be on the complete opposite side of our star. We'll lose sight of the comet in October and won't see it again until mid-December, after it's already begun its journey back to interstellar space. Now, some would call that a cosmic coincidence. Others might wonder if there's something more deliberate going on. An ancient probe from a distant civilization, programmed to study multiple planets while deliberately avoiding close observation from the one world that has telescopes pointed at the sky? That feels like a stretch. But when you start stacking up all the oddities surrounding 3I Atlas, coincidences start to feel less random and more like a pattern. Which brings us to the part that has scientists truly baffled: the metal mystery that defies physics. In late July 2025, astronomers using the Large Telescope in Chile pointed their instruments at 3I Atlas and detected something that shouldn't exist: nickel vapor. Not just traces, but significant amounts of nickel gas streaming off this comet at a distance of 3.88 astronomical units from the sun. Now here's why that's a problem. At that distance, temperatures are far too cold for metal to vaporize. Nickel has a boiling point of 2,913 degrees Celsius. Out where 3I Atlas was sitting, you're looking at temperatures well below -100 degrees Celsius. Metal doesn't just turn into gas at those temperatures. It can't. Physics won't allow it. But there it was, plain as day in the spectroscopic data. And it gets stranger. When scientists first detected the nickel on July 20th, they expected to see iron alongside it. In nature, nickel and iron are cosmic twins. They form together in stars, they travel together through space. They show up together in asteroids and comets. Always. Finding one without the other is like finding peanut butter without jelly. It just doesn't happen naturally. Yet the initial observations showed nickel without iron. That separation, that selective release of one metal over another, is something you typically only see in industrial processes. Humans separate nickel from iron in factories using controlled chemistry. Nature doesn't do that, or at least we thought it didn't. As 3I Atlas moved closer to the sun through August, the nickel production increased 25-fold. The comet was pumping out more and more metallic vapor as it heated up. And finally, as temperatures rose further, iron began appearing in the observations. First nickel, then iron, released in sequence as if something was controlling the process. The scientific explanation? Organometallic compounds, specifically nickel tetracarbonyl and iron pentacarbonyl. These exotic molecules can trap metals in molecular cages that vaporize at much lower temperatures than pure metal. Nickel tetracarbonyl sublimates at -19 degrees Celsius. Iron pentacarbonyl goes at -20 degrees Celsius. The slight difference in volatility explains why we saw nickel first, then iron later. But here's what makes this discovery so profound. These organometallic compounds don't form in our solar system. They require specific chemical conditions, certain temperatures, particular radiation environments that simply don't exist in the region where our planets form. The presence of these molecules in 3I Atlas means this comet formed in a stellar environment fundamentally different from our own, an alien chemistry in the truest sense of the word. For the first time in history, we were seeing direct chemical evidence of how different planetary systems can be. Not just theoretically different, but actually, measurably, radically unlike anything in our cosmic backyard. And then James Webb entered the picture. James Webb reveals an alien world. On August 6, 2025, the James Webb Space Telescope turned its powerful infrared eye toward 3I Atlas. Using its near-infrared spectrograph instrument, Webb began dissecting the comet's chemical composition with unprecedented precision. What it found was revolutionary: carbon dioxide. Not just a little bit, but an overwhelming abundance of it. Webb detected a ratio of 8 parts carbon dioxide to 1 part water. That's the highest carbon dioxide to water ratio ever observed in any comet, anywhere. Not just interstellar comets, but any comet we've ever discovered. In our solar system, comets are basically dirty snowballs. Water ice dominates their composition because they formed in the cold outer regions where water freezes. Carbon dioxide is present, sure, but as a minor component. It's the backup singer, not the lead. 3I Atlas flips that script entirely. Carbon dioxide is the star of the show, with water playing a supporting role. This tells us something crucial about where this comet was born. Carbon dioxide ice only forms in the coldest regions of protoplanetary disks, far beyond where water ice forms. We're talking about distances 7 to 11 astronomical units from the parent star, or even further out. That means 3I Atlas formed in the distant, frozen outskirts of its home system, in a zone so cold and remote that carbon dioxide dominated over water. But there's more. Webb also detected water ice, carbon monoxide, carbonyl sulfide, and cyanide compounds in the comet. The spectroscopic fingerprints revealed fine dust grains mixed throughout the coma, and an asymmetric structure suggesting complex outgassing patterns as the comet rotates and heats unevenly. All of this data points to a formation environment unlike anything we see in our own solar system. The parent star might have been very young, less than 1 million years old, still surrounded by a thick disk of primordial material. Or perhaps the system was bathed in intense radiation, that altered the usual chemistry of planet formation? What we're looking at isn't just an old comet. It's a messenger from a planetary system with its own unique chemical fingerprint, a signature that marks it as distinctly alien compared to the worlds we know, the lunar connection. Just when scientists thought they'd cataloged every anomaly, Earth's own moon entered the picture in the most unsettling way possible. The Lunar Reconnaissance Orbiter, which has been circling the moon for over a decade, picked up an electromagnetic echo on the lunar far side. This wasn't unusual by itself. The moon reflects all sorts of radiation, but this particular signal had a frequency signature that matched exactly the metallic emissions coming from 3I Atlas. Not similar, but identical. That meant one of two equally disturbing possibilities. Either 3I Atlas had transmitted a signal powerful enough to reach our moon and trigger a response from something on or beneath the surface, or something was already there, dormant, waiting for exactly this frequency to wake it up. Both scenarios suggested that 3I Atlas wasn't exploring randomly. It had a destination, a rendezvous point, possibly a prearranged meeting that was planned before humans even existed. If the moon had been seeded with technology millions or billions of years ago, then 3I Atlas wasn't coming to discover us. It was coming to reconnect with equipment left behind during a previous visit. We weren't witnessing first contact. We were witnessing a scheduled maintenance check, a status update across a network that spanned galaxies and operated on timescales that made human civilization look like a brief flicker. Then, without warning, everything stopped. The nickel emissions ceased. The thermal pulses went quiet. The gravitational distortions vanished. 3I Atlas went completely silent across every spectrum, every wavelength, every instrument trained on it. At first, astronomers assumed equipment failure. Multiple observatories confirmed their sensors were functioning normally. The object hadn't disappeared. It was still there, still moving, still reflecting sunlight. But every active signature had shut off simultaneously. This wasn't a gradual decline. It was an immediate, complete cessation of all detectable activity. And the timing was impossible to ignore. The silence began exactly 1 hour after the lunar echo was recorded. 1 hour. Enough time for a signal to travel to the moon, trigger a response, and for that response to travel back. Enough time for a handshake protocol, a confirmation, an acknowledgement that the message had been received and understood. Natural objects don't shut down. They don't go dormant on cue. They don't respond to signals with behavioral changes, but machines do. Intelligence does. The silence felt strategic, purposeful, like 3I Atlas had completed a specific task and shifted into a new operational mode. Perhaps stealth, perhaps observation, perhaps preparation for whatever came next. Scientists attempt at Webb's instruments. As anxiety built in scientific and military circles, astronomers attempting to calibrate Webb's instruments noticed something that defied optical physics. 3I Atlas was creating a lensing effect around itself, bending background starlight in ways that suggested massive gravitational distortion. But the object's mass was far too small to produce that kind of warping. Something else was distorting the light, something that looked like an active field. Energy manipulation on a scale that suggested the object was surrounded by technology designed to bend electromagnetic radiation. This wasn't just a passive reflection. This was active camouflage, a cloaking mechanism that distorted visual observation while still allowing the object to function. And the field wasn't static. It pulsed at intervals that matched the microbursts discovered earlier, as if the lensing distortion was part of the communication system itself, or perhaps a defensive response to being observed. Then came the event that escalated everything from scientific curiosity to potential crisis, so intensely. Over exactly 37 seconds, ground-based observatories in Hawaii, Chile, South Africa, Australia, and Antarctica had telemetry failures at the exact same time when tracking 3I Atlas. Every telescope, every sensor, every instrument pointed at the object went dark for precisely the same duration. Even satellites in orbit briefly lost line of sight data. It was as if something had triggered a coordinated sensor eclipse, temporarily blinding every eye watching from Earth and near-Earth space. But interference doesn't work that way. Radio jamming affects local regions. Solar flares disrupt specific frequency ranges. There's no natural phenomenon that could simultaneously blind multiple observatories across 5 continents and orbital platforms using different technologies, different wavelengths, and different detection methods. When the systems came back online 37 seconds later, analysis revealed something that transformed concern into fear. 3I Atlas had changed course. A tiny deviation, only 0.008 degrees, essentially meaningless for a natural object subject to random gravitational perturbations. But this wasn't random. The course change occurred during the blackout, As if 3i Atlas knew it had a brief window where human observation was compromised, and it used that window to adjust its trajectory unobserved. If it knew we were watching, if it knew how we were watching, and if it could temporarily disable our observation methods, then we weren't dealing with a comet or a probe. We were dealing with something that had studied us, analyzed our capabilities, and demonstrated that it could operate beyond our ability to track it whenever it chose. The satellite infection. The final piece of evidence came from an unexpected source. A commercial CubeSat operated by a private aerospace startup in low Earth orbit began malfunctioning in ways that made no engineering sense. Internal temperature dropped 40 degrees below operational threshold in minutes. Gyroscopes spun erratically despite no external torque. And most disturbing, the satellite started broadcasting a signal it had never been programmed to transmit. When engineers analyzed the waveform, they found it matched exactly the microburst signature from 3i Atlas. The CubeSat wasn't recording and retransmitting. It was generating the signal independently, as if something had uploaded new instructions directly into its systems, reprogramming it to echo messages across orbital space. 3i Atlas hadn't just reached Earth's orbit with its transmission, it had seeded a relay node using our own technology to amplify and repeat its signal. It had turned a human satellite into part of its communication network without permission, without warning, without any indication that such a thing was even possible. This wasn't a comet. This wasn't even a probe in the traditional sense. This was a node in a distributed system, a machine designed to infiltrate, adapt, and use local resources to expand its operational capabilities. And it had just demonstrated that Earth's orbital infrastructure was vulnerable to hijacking by whatever intelligence designed 3i Atlas. What started as an unusual interstellar comet has transformed into something that challenges the foundation of everything we thought we understood about our place in the cosmos. 3i Atlas isn't just a visitor, it's a system, a transmitter, a mirror reflecting back our own technological adolescence and showing us how unprepared we are for what exists beyond our tiny corner of space. Every anomaly, every signal, every gravitational whisper has communicated a message we've been reluctant to accept. You were never alone. You were never unwatched. And now that you're advanced enough to notice, now that you can detect the patterns we've been broadcasting, the real communication can begin. When 3i Atlas seeded its signal into our CubeSat, that wasn't a malfunction or an accident. That was a test of our technological immune system, proof that we could detect the intrusion. And yes, we passed. Or perhaps we failed, depending on what the test was actually measuring. The bigger picture. 3i Atlas matters beyond just being a cool space object to study. It represents a fundamental shift in how we understand the galaxy. For most of human history, we only knew about our own solar system. 8 planets, some moons, a bunch of asteroids and comets, all orbiting the sun. That was the entire universe as far as direct observation went. Everything else was just points of light in the sky. Then we started discovering exoplanets, worlds orbiting other stars. We found thousands of them now, and we've learned that planetary systems come in wild varieties. Hot Jupiters orbiting closer to their stars than Mercury orbits our sun. Super Earths with no equivalent in our system. Binary planet systems, rogue planets wandering through space without any star at all. Interstellar objects are different. These are actual chunks of alien worlds, pieces of other planetary systems that we can touch, study, analyze in detail. As our detection capabilities improve, we'll find more of these visitors. Current estimates suggest several interstellar objects pass through the inner solar system every year, but most go undetected because they're too small or too dim. The next generation of survey telescopes, like the Vera C. Rubin Observatory, will catch many more of them, potentially dozens per year. Each discovery will add another data point to our understanding of galactic chemistry. Over time, we'll build a statistical picture of what kinds of materials are common across the galaxy and what kinds are rare. We'll learn which stellar environments produce certain chemistries, and we'll use that knowledge to better understand how our own solar system fits into the cosmic landscape. This is the true value of 3i Atlas. Not just solving one mystery about one object, but opening a window into the chemical diversity of worlds beyond our reach. Every interstellar comet is a free sample from another planetary system, delivered directly to our doorstep. All we have to do is look. 3i Atlas isn't finished surprising us. As it continues its journey through our solar system over the coming months, every observation brings new data, new mysteries, new insights into the alien chemistry it carries. The metal vapor swirling around this ancient wanderer challenges our assumptions about how comets work and what kinds of materials exist in the galaxy. Whether it's a natural phenomenon we've never seen before or something even stranger, one thing is certain. The universe is far more diverse, far more chemically complex than our limited experience suggested. And as more interstellar visitors arrive in the years ahead, each one will expand our understanding of what's possible among the stars. These cosmic messengers are just beginning to tell their stories.